Alright, so this will be the review sheet 17 quick video, so hopefully this will help you out. I think it will. First one here, we've done 100 of these throughout the year. We are taking these different amounts of suckers and Twizzlers and we are putting them into bags. Another word for bags would be, whoops, that's white. Another word for bags would be putting something into groups. If you don't remember what you would be doing on this, also the word identical would be there. But really, when you're taking any of these amounts and you're putting them into groups, you have to do some work on this one. Okay, you might want to look back to previous review sheets because we've had one of these on pretty much every review sheet. It was from chapter 1 though, so if you want to look back to your chapter 1 notes, that should help you. And then this, you'll be able to, once you figure out that, you'll be able to figure this out. Okay, adding and subtracting fractions. If you're ever confused on adding and subtracting fractions, you can always you pretty much go to YouTube and you can type in subtracting fractions. It'll probably have a million videos come up that will help you to remember how to do this. I'll do a quick little reminder. First of all, you got to have a common denominator. Okay, now remember there's something called the LCD. That is the least common denominator. That's where you find the LCM of your two denominators. Okay, so you actually would, if you needed to go over and do your trees of 8 and 5, find the LCM, that would be here. That would be your denominator. The other one that you guys have learned this year is the QCD. Now the QCD, remember, is the quick common denominator. Quick common denominator. That's the one where you just simply multiply the two denominators together to give you a common. Just remember, whatever you do to the bottom, you must do to the top. Okay? This one here, same rules apply. You're adding, so you're going to have to find a common denominator. I would go ahead and go around the barn if I were you. That's my advice to you. You don't have to, but I like you guys to do that. So what I would do is, first step is I would make that 7 over 5 plus 3 over 2. And then find a common from there. This one can really trick people up a little bit. Okay, because it looks a little bit different. But just like the one I just talked about, first thing you're going to want to do is you're going to want to turn them into improper fractions. Okay. Now, some of you might say, well, wait a minute, how do I make that improper? Well, you all know how to do that. Every whole number has got a denominator of 1. So you would do that, and then you would say, okay, go around the barn here. That's going to be 25 over 6. And then from here, just find a common denominator. Again, you could use the QCD. 1 times 6 would give you a denominator of 6. Okay, so then you would, if you want to make this 6, then whatever you did at the bottom, you do the top, and then subtract and simplify. That's it. Make sure you simplify all your answers. If you don't, it will be incorrect. If you don't show work finding a common denominator, it will be wrong. Okay? All right. Next one. This is right from Chapter 5. We did one of these on your Chapter 5 formative and summative. Okay, here's your fake ratio. There are 24 girls and 16 boys in band. Okay, so you have 24 girls. You have 16 boys. Okay, if you were to add 9 girls and you were to add 6 boys, or they joined the choir, would the ratio be the same? So what you're going to do is you're going to go ahead and add on those 9 girls. You're going to add on those 6 boys, and you're going to get a new ratio. Okay? You're going to get a new girls to boys ratio. And basically all you're going to do here is you're going to say, okay, that's my fake ratio, that's my real ratio. I am going to compare them. You guys know 4 methods of comparing. Or actually, I should say 3 methods and a little fourth. That's how I said it the whole time when we did it in Chapter 4 and 5. 3 methods to check for equivalency. Okay? If you're not sure, look back to your Chapter 4 and your Chapter 5 notes. It will be in there. Okay? All right. This one, during the sale, you can buy 4 uniforms for $215.69. We want to know the unit price. You remember the unit price is the cost per one of the object. So you're obviously going to have to show a proportion here because that's the only way I showed you how to do it. And since we're doing unit price, remember money always goes in the top. Therefore, uniforms has to go in the bottom. Your fake ratio then is $215.69 for 4 uniforms. Well, if we want to know the unit price, we want to know how much one uniform costs. Okay? Then, once you figure out that information, okay, Now you're down here. Well, if you know that this is your unit rate or your unit price, you're going to take that and you're going to do another proportion, only now you're going to put 13 uniforms. So you're going to have another proportion with uniforms in the bottom, money in the top. You're going to take the pink one, that right there, and you'll stick that there, and then you'll put 13 there, and then just solve to figure out that. Okay? Look back to chapter 5. That was one of those. There was one in your chapter 5 formative and summative about a snowstorm that was like that. There was one about a race car, I think. Okay. All right. Here, this is chapter 3. So any issues at all, look back to your chapter 3 notes. The first thing you've got to know when you are multiplying, in this case we're multiplying mixed numbers, you have to convert them. You have to go around the barn. You have to make this 9/8 times 3 times 5 is 15 plus 1 is 16, and the denominator stays the same. Now remember, when it's multiplication, you can cross simplify, okay, if you want. That's a good method to use. Remember, that's just where you say what factor does 8 and 16 share, and then divide it out. What factor does 9 and 3 share? Divide it out. Okay, or you can just do top times top, bottom times bottom, and then simplify at the end. But I think cross simplifying is a little easier because the numbers are smaller when you're cross simplifying. Okay, same with this one here. First thing you're going to have to do is convert them to impropers. This one's already in fraction form, so you don't have to do anything with that one. But this one you will definitely have to convert. Okay, now this one is a division problem. So remember, I need to see 2 steps. If I don't see 2 steps, it will be wrong. I will count it wrong. Step number 1, remember, put them in fraction form. So that means you got to go around the barn. So if we did that, I won't write what it is. There's my 2 fractions. We leave it as a division problem when we put them in fraction form. Now step 2 is when we do the algorithm for dividing fractions. And you guys will remember that as division is just multiplying by the divisor's reciprocal. Again, all in your chapter 3 notes. If you look back to that, you will immediately find it. It's probably on the first couple pages. Okay? Here, how many operations? We've done a ton of these. Just keep in mind, you have your basic ones here. Those are the ones that are really easy to see, but that's not all there are. There is more than that. Okay, so you can go through and count those. I told you before break that you no longer are required to write PEMDAS, but if you're somebody that's just gotten the habit of it, just keep doing it. I always write it just to make sure I'm keep everything straight. And then once you follow it, remember, once you get done, go ahead and plug it in your calculator just to make sure that you didn't make an error somewhere. Okay, this is chapter 5. So this is the stuff we did right before break there. Here's your fake information. In a bag of blue and red marbles, I have the following ratio of blue to total. So if you guys, hopefully, if you took anything from what I've taught you, hopefully you have, obviously, I always like you to do edge pieces. So I know that means there are 3 blue, because that goes with that. And that means there are 5 total, which means there are 2 reds in there as well. Okay? Now we go to what I called my that's too big. Hang on. Now I go into my real information. And there it is. Usually real information starts with the word if. If I have this, then how many of this do I have? Something like that. Remember, the first thing we put on our proportion is we put labels. So we know we are being given red, so we know that that's going to be one of the labels. Okay, and we're being asked, we are being given blue. It doesn't matter. And we're being asked for red. So it doesn't matter whether you did red to blue, or you could do blue to red. Okay, I meant to write blue there, but it doesn't matter. Okay, the only time it matters is when you're given a total. You have to put total in the second term, the bottom. Okay? Now my fake ratio is I've always put it in yellow. Okay? I get that information from this table up here. And then you just go up there, plug in whatever comes from this. Your ratio of red to blue is right there. And then you put in your real information, which is right there, and then solve for how many reds there would be. Okay? This question right here, there was a small error, so if you didn't fix this, make sure you fix it now. This should be $324.99. $2.95. Okay, that's a mistake on my part. That's the way it is written down here, but I had it differently up there. So just make sure you fix it. Okay. I kind of laid this one out pretty easy for you here, because I mean, this is chapter 6. This is where we're going right now. This is what we're getting ready to start. We're starting this week, and we're going to finish in the next couple weeks. Okay. Now, with this right here, though, I really laid it out there for you and made it easy for you, because you just have to figure out how much I'm saving. So we just got to know, it tells you to do multiplication, 30 cents times the amount of the hood ornament. Okay? Now, the problem is you guys can't just type a percent sign into your calculator, so you've got to convert it to a regular number. Now, there's two ways to do it. The first way is just to know that, remember, like when you guys figure your grades and say you got 0.89 on something, you guys know that when you are turning it into a percentage, you multiply it by 100, and that's where you get 89%. You move the decimal 2 places to the right. Well, the same goes for if you have a percent and you're trying to turn it to a regular number, you're going to move it 2 places to the left. Okay, so that's something you could do. The decimal in 30 is right there, so move it 2 to the left. That's 0.30. And then you just do 0.30 times 324.95. And that's all you do. Now, if you didn't know that, what you can do is you can know, okay, 30% is a fraction out of 100. So it's 30 out of 100. Okay? And then you know that all fractions are division problems, so just do 30 divided by 100, and that would give you 0.3, which is the same as 0.30. So either way, and then when you multiply that, you'll get the answer. All right. I don't know where I left off. Sorry, the phone rang. Okay, here. Write the following values as a fraction and as a percent. So you should all be doing like a column for fractions and then a column for percentages. Okay? So when you got to remember, when you're turning a decimal into a percent, you have to say the number like the real way. You just can't say 0.53, 1.67. So I'm going to do an example down here. I'll just do, this will be the one that I'll do for you, and then you can kind of use this to help guide you. Okay, now you've got to remember what the place values are, and that's what a lot of you struggle with still, and it's something that you should have down better, especially as much as I'm trying to hit on it, but it's something that you should have really, you should have mastered from elementary, and a lot of you are really struggling with what your place values are. If you're ever struggling with what place values are what, you can always go to Google and just type in place values, and it'll help you out. Okay, so when you're making this into a fraction, you know that it's going to be 82. You just say the number, so it's 82. Your denominator is going to be whatever place value it's in. So in this case, it's hundredths, so it's going to be 82 hundredths. Okay? Now you'd have to simplify that also. Now I'm going to skip that step just because. But if you don't simplify it, I guess I can just simplify it real quick. Whatever. They're both even. That's going to be 41 50ths, and that would be in simplest form there. So that would be your fraction. If this was 822, then it would be 822 over 1,000 because it ends in the thousandths. If it was 0.9, then it would be 9 tenths. You guys get how that works? So remember, it's tenths, hundredths, thousandths. And if it ends in this one, it's going to be out of 100. If it ends in this one, it's going to be out of 1,000. If it's out of this one, it's going to end in tenths or tens. It's going to end in 10. Okay? All right, so we've already done that. Now, if we're ready to turn this into a percent, I really should have flip-flopped these, really. That's actually easier to do it. I think it's easier to go from this to a percentage than to a fraction. But that's okay. Regardless, you know right here that anything that's out of 100 is automatically the percentage. So that would be 82% right there. Okay? All right. This one, you would say this. You got to be real careful with this one. This is 17. So you just say the number, so I only see 17. And then since the 7's in the thousandths, it would be 17 over 1,000. Okay? And that would be in simplest form, and then you turn that into a percentage. So, again, taking this and moving the decimal 1, 2, like we talked about up there. Any decimal, any number can become a percentage by multiplying by 100 or just simply moving the decimal 2 places to the right. Okay? These are just definitions you can look through. This would be chapter 4. This was in chapter 5. This was in chapter 2. This was in chapter 3. So they're all in your notes, word for word. No reason for anybody to miss those. Just look back in your notes and they're all there. Okay? All right, this question here. Okay, this is going to be proportion. You should show a proportion here. Okay, this right here is the fake ratio, but the only thing that makes this kind of tricky is you can't put 3 labels. I can't put money, hours, and minutes on my proportion. You can only have 2 labels. So we know that money has to be one of them because that's what we're trying to, I mean, obviously it's money being compared to time. You've got to convert this. It can happen 2 ways. You can either convert it to hours or you can convert it to minutes. So if I were going to convert this to hours, I know that that's 1 whole hour, and then 30 minutes would be half of another hour. So you could do it like that and then do 120 and then just put your real information on there. 6 hours. Like that. And then just cross multiply divide. The other way you can do it, if you didn't want to convert it to hours, you could convert it to minutes. Okay? So you could do minutes on the bottom, and then in 1 hour and 30 minutes would be 90 minutes. And that would be 120 for every 90 minutes. The only thing here is it gives you 6 hours. You've got to convert that to minutes and put it right there. Okay? So either way you want to do it on that one. This question, it's a lot harder than what it has to be. Every one of these dots is representing how they can reach their goal. Okay? So if you haven't read it, pause it and read it so you actually know what I'm talking about. Okay? Every one of these dots is representing how many vans, like for instance, if they did 60 vans, they would reach their goal of $360. So if they did 60 vans, they wouldn't even have to do any cars. Okay? Same goes over here. If we kept this thing going forever, eventually we could figure out how many cars we would need. But I could pick any spot. I could go here and say, oh, okay, this means that if they do 60 cars, they have to do at least 20 vans. And if they do those 2 amounts, they'll reach their goal of 360. Okay, so that's all this question's saying. It's very easy, actually. Okay. Down here, we know how many vans they washed. So if they washed 30 vans, we just kind of follow this over and then figure out how many cars it is. Basically, just gave you the answer. All right. This one, tricky question. This was a part question from last year. Okay. Here's a rug. We know that the area formula for a rectangle is area equals base times height. What's different here is it's giving us the area. So I would like you to remind you of this. Whole equals part times part. Since I know the area and I know one of the parts, in this case I know the length, or what I would call the base, but same thing, what operation are we going to do if we're trying to figure out this other part there? Hopefully you're all saying division. We're going to do whole divided by part equals part. Okay? And then obviously you need work here showing how you divided it. Okay? Okay. This question here, the best way to go about this one, to be honest, is to kind of go through and kind of make up an example. So the median number of points scored by 9 players in a basketball game was 12. So you know that there were all these numbers, number. We know that the median, or the middle number, is 12. Okay? The range of the number of points scored by the same players in the game was 7. So you know that this, if we're calling this right here the maximum, and we're calling this the minimum, we know that that's the range is 7. So based on that, we need to figure out what's true here. Okay? So what I did is I kind of said, okay, what if I just made up numbers, and I said if this was 15, if the maximum number of points scored was 15, and since my range is 7, then that means that the minimum one I made up must be 8, because 15 minus 8 is 7. Okay? Now, based on that information, go through and you got to figure out which one you feel would be true in this situation. Okay? It's kind of a tricky question, but we'll see how you guys do on that one. I want to kind of see where you're at on that one. This one, basic stuff here. Can't use a calculator. You can check with a calculator, but your work has to match there. You absolutely have to show it. Onto the back. People have been getting a little bit confused on this one. I'm just going to remind everybody of this property that we learned back in chapter 1 called the distributive property. Now you're not going to get an answer, as you can see. You're going to get an expression. Okay, so I'm going to stop there and let you guys think about that one. You just got to think about which, if pick all that apply that's equivalent to that, equal. Okay. I think you guys can figure this one out. I'm not going to talk too much. If you need to draw a number line, go for it. You may need to find common denominators to actually be able to tell what's larger or what's smaller. Something you could do. But just think about it. If you had 0, -1, -2, if you had 1, 2, think about which number would be furthest to the left and which one would be furthest to the right. The number line will really help you. Trust me. And then finally here, you can check with the calculator, but you must show work. Just keep in mind the problem that I would have had you do is 183 times 439. And then from there, do all the algorithm that you know how to do, then put your decimals in later. Just note that one of these boxes, you actually have to put the decimal in. So if let's say the decimal's right there, you actually got to put it right there, like that. Bring it up, and then that actually is a spot, if that makes sense. So it can't be like if your answer was like 22.9, if that was the answer, you just can't do like 22.9 like that. The decimal actually has to take a spot, so it'd have to be written like that. Okay? All right. Okay, I think that's it. So hopefully this helped you.